Happy Wednesday, friends. I hope you're doing well and I hope you're ready for today's version of Number Corner because guess what? It's our first problem string of the month. But before we get there, let me quickly show you what our calendar marker looks like for today. We know we have a pattern happening. We have a quadrilateral, a pentagon, and a triangle. Obviously, the triangles are different and the quadrilaterals are sometimes different. The pentagons look different. And we've talked about some of the geometric terms that you should know that correlate to what we're seeing on our calendar grid, such as scalene, isosceles, equilateral, or even the word regular for a regular polygon. So I hope that you're familiar with these terms. Without further ado, here is today's calendar marker. As expected, it is April 14th. We are on our 5th day of school in April, and we have a quadrilateral. It's following our pattern. It tells us the area, and we know we're finding the perimeter, which is adding up all the sides. So I will update that for us so that when we're talking about our calendar grid again, we will talk more in depth about how to do that. But hopefully you're thinking, what times 7 would give me 14? And then knowing that this side equals this side, and then adding them up. Now, I want to update our calendar collector. So here's our 5th day. Oh my gosh. We have now completed 1/2 of a meter. And a meter is 100 centimeters. So look, we have 5 decimeters. And in a decimeter, they're 10 centimeters. So this will be 10, 20, 30, 40, 50. So far, we've collected 50 centimeters, which is 1/2 of a meter. But we'll talk about that some more another day. Now to our problem string. Before we get started, let's review some very important math terms that you should know in relationship to division, because this month, we're going to continue to explore division strategies so that you can understand division more deeply and acquire additional efficient strategies for division to help you solve the problem. When I say efficient, that means you can choose a strategy that works best for the problem that's given, and you're accurate every time, and it's fairly quick also. So, before we get to our problem string, let's look at some of these terms. We have quotient, divisor, and dividend. The quotient is the answer. So, if you look at a rectangle here, here is our area, 18. Here could be what we're dividing it by, and then here could be our answer. So maybe A is our quotient in this particular problem. So that makes this our, let's try that again. That makes C our dividend. That's what the total we're going to divide into different groups or into, so we have grouping division, and then we have division where we're putting a certain amount in each group, okay? And that means this is our divisor. That's what we're dividing by. Are we dividing it in 6 groups? Are we putting 6 in each group? So, can you guess? Again, we have the same problem. Now it just looks a little different. And maybe you see that this bar right here actually comes from our rectangle here, our area model. Here's the bar, here's 18, here's the bar, and here's our 6, and the 3 goes on top. So it's the same thing. That means D is our dividend, F is our divisor, and E is our quotient. Now, this kind of looks like what we were doing last month with our calendar collector. That's fractions. This is an improper fraction, and then this is a whole number, because fractions is just like division, 18 divided by 6. So 18, if I'm looking at 18/6, I could read it as 18 divided by 6, which means 18 is our dividend. It's in a different location. Still has the same meaning. H is our divisor, and 3 is our answer, which we call a quotient when we're talking about division. Okay? All right, so let's get started with the very first problem on our problem string. And this first one might be really easy for you, but I want to remind you that when we do problem strings, The earlier problems are supposed to be easier because we're supposed to use what we know from the earlier problem to help us with the problems that are going to come afterwards. Okay, so it will progressively get more difficult. So here we go for number 1. 48 divided by 8. What do we know? What is it? You should know your facts. I hope you know your facts. Good. The answer is 6 indeed. How do you know it's 6? Hopefully you're thinking 6 times 8 equals 48. Okay, I'm not going to draw a picture for that just yet, but I will in just a second. Let's look at the second problem. 48 divided by 4. Before you try to solve this problem, or before you just call out the answer because maybe you know this fact as well, let's think about how is 48 divided by 8 and 48 divided by 4 like? Is there a relationship? So I'm going to go ahead and make my quadrilateral here. And my shorter side is going to be my 6. And my longer side is going to be my 8, trying to keep it proportional, which means my dividend goes here, which was 48. Do you all agree? Okay. Well, we still have, oops, that's not an 8. We still have our 6. Not our 6, excuse me. We still have our 48, but now we have 4 over here if we're going to draw the same picture. So watch what happens. Look, it's half the size, right? I still have 48 here, and I have 4 here now. So I'm cutting this in half. Really, and I probably should move this, because really what I'm doing is I'm taking this piece in order to keep it the same area or the same amount of space. I essentially took this piece and I shifted it and moved it right next door here. And so I'm going to show that by adding some lines like this. Maybe you can see that better. And this whole thing is now 48. Does that make sense? Do you see it? Okay, so this whole thing has to now be 48. Because I actually cut my dividend in half. I halved it. And earlier we had 6 here, which means, what do we have here? We have 6. So what is our answer this time? Our answer is 12. We halved the divisor. And that means we had to have, or double, excuse me, we had to double our quotient, okay? So when we have our divisor, we're doubling our quotient. And you can see that by looking at this illustration here. I cut this side in half, but in order to keep the same area, because I can't hold up this piece of paper, I can't hold up this piece of paper and say that this whole area is 48, and then say this is 48. In order to keep it 48, I'd have to cut this in half and move it over, okay? But now my dimensions have changed. So let's use that same thinking to look at the next problem, which is 48 divided by 2. All right, do you see what's happening here? If not, let me just go ahead and say it. I am having my divisor again, which means what am I doing to my quotient? I'm having it this way, and I'm sliding this whole piece over here. So now it would look something like this. Oops. Let me do this the right way here. It might look something like this. Instead of having 4, I now have 2. I had 12 when it was like about this long. So now what am I doing? I'm doubling my quotient. Which means, what is my answer? My answer is 24. Very good. So here's the big idea for this set of our problem string. When you keep the dividend, and that's why we need to know these terms, guys. When you keep the dividend the same, so the total, the amount that you're dividing, when you keep that number the same, but your dividend is halved, that means your quotient has to be doubled. And so again, I'm going to demonstrate that with a piece of paper. So here's my piece of paper. I'm going to make myself really big. Here's my piece of paper. And I'm saying that this has an area of 48. If I want to change the dimensions, so let's just say this is my, I'm going to do it this way. This, we had 6 here, and this is 8 because this side's longer. And I'm making 8, I'm cutting 8 in half. I'm going to do my best to cut it in half here. This is still 48 because I'm not adding anything to it, I'm not taking anything away. But now that I have a dimension of 4, I'm sliding it over here. So my 6 that was on top is now doubled. So I could tape this together. And if I wanted to do that again, I have to cut it in half again. And I'm now still doubling my quotient. Does that make sense? I hope so. Okay, back to our problem string. Let's look at our fourth problem. Maybe. 36 divided by 2. This time we have a different dividend. So now we're going to reshape our thinking here. 36 divided by 2. What times 2 would give us 36? Thinking about our relationship between multiplication and division. What times 2 equals 36? Okay, did you say 18? That is correct. So if I were to draw that out, it would look maybe something like this. It would be really long and skinny. So 2, and then 18 would be our answer because this is 36. Here's my 2, and then my quotient goes up here, which would be 18. 2 times 18 is 36, because 18 plus 18 is 36. Okay, so now let's look at our next problem. 36 divided by 4. What's the relationship, guys? We kept our dividend the same, but we didn't have our divisor. We doubled it. So watch what's going to happen. So I still have 36, but instead of having 2 here, I have 4, which means I essentially have to cut this in half and move it down here. So what does that mean is happening to my quotient? It's getting cut in half. So it's the opposite of what I just did. So if this is 36 and this is 2 and this was 18, now I have 4. I had to cut it, move it so that I have 4, and now it's we're doubling our divisor, which means we're having our quotient. So it's the opposite. So this time we would get 9. Okay? So then now we have the same dividend, 36 divided by 8. So I'm going to take my same picture here, and I really hope you guys are following me. And I'm doubling that. So now I have another 4, which gives me a total of 8. But where am I getting it from? Because I'm not adding any to my area. Not adding anything. I have to take this piece and cut it and shift it. And I really hope that you guys understand what I'm drawing here. I probably should have done, the lines that look like this. But hopefully you now see it. So I'm doubling my divisor, which means I am halving my quotient. What's half of 9? Half of 9 is actually 4.5, because 4 plus 4 is 8, and then a half plus a half is 9. So, first we talked about when you have your divisor, you're doubling your quotient. When you double your divisor, you're halving your quotient. Let's see what happens if we mess with our dividend. So that means our starting number is going to change. 24 divided by 6. You guys know it. What is it? Good. 24 divided by 6 is 4, because 6 times 4 is 24. So then I have 48 divided by 6. Oh, how are these numbers related? What did I do here? I doubled 24. Yikers. So let me draw this out. Here's my 24. This is probably not as proportional as I would like it. Shame on Miss Trammell. And here was my 4. But this time, I am doubling it. I now have another 24. I have 48. And I want to know what my quotient is going to be. Let me think about this for a second. I don't know if my picture is doing my thinking justice. I had 24 and I put them in 6 groups. Now I'm doubling the amount that I have, but I still want to put it in 6 groups. How can I do that? What's going to happen to my quotient? Well, you know what? I probably did. I messed up my picture. Let me draw it the opposite way. Because I still had 6. I was confusing myself. Still have 6 here, so I'm actually doubling the amount that I have that I want to put into 6 groups. So that means I'm doubling my quotient. Good. 48 divided by 6 is 8. Okay, let's look at the next one. 96 divided by 6. Oh no, I doubled it again, which means I have to take what I've done here and double it. And I'm going to change my color to double it because that was 8. I'm adding another 48, and we knew that 48 divided by 6 was 8. So now I have 8 plus 8, which is what? 16. So this time, first we halved our divisor, which means we had to double our quotient. Then we doubled our divisor, which means we halved our quotient, and I know this is a lot. Now you're telling me we're doubling our dividend, and that also means we're doubling our quotient. So it sounds to me like when you double a number, then you're when you're doubling a number, you're doubling your answer, right? When you have a number, and that's not right. Miss Trammell, get it together. Woo, this is a lot. You know what? We're going to stop here for today, and we're going to look at the big ideas of what we were doing with this problem string. And if you don't get it today, it's okay, because we will do more problem strings like this month. When you have your divisor, your quotient is doubling. Okay? When you're doubling your divisor, the quotient is halving. So it's doing the opposite. Okay? But when you double your dividend, the quotient also doubles. So you're doubling your first number, then your answer also doubles. Now you're doing the same thing. Before it was you're doing the opposite. If you were to have the dividend, which we didn't get to today for the sake of time, then you would also be having your quotient. So as long as your dividend, your first number, the total that you're dividing is staying the same, but you're changing that second number, whether you're doubling it or halving it, then the answer is going to be opposite of what you did. But if your first number is the one that's changing by double or half, then that means your answer is going to do exactly what the dividend did. So I know that was a lot for today. Even Miss Trammell got a little confused, and that's okay because we're learning together. But we just got to make the effort to get there and make the effort to be accurate and to understand what's really happening. So we will continue to work on problem strings this month and talk about why using some of these strategies would be useful when solving division problems. So hang in there. We're going to get there. April is just starting out. I have full confidence in you. You guys have a great rest of your day, and I will see you tomorrow.